Sahil. What about others? Can others tell me whether the voice is loud and clear or is there a break in between?
Jitendra this side, I am receiving your voice clearly. There's no breakage.
Sparsh this side, receiving your voice clearly.
So, okay, Pawan. So we can go ahead. So this is the brief background of our participants. As I told, we all are having engineering background, and most of us are from computer science.
Yeah. Thank you very much, Sahil and Kevna, Vishal, and Anurag for confirming. And probably if you still have the same issue, you can consider rejoining as well. However, okay. And have you guys also have any exposure to Python programming? Like the basics of Python? Okay, so I see. So I see some of you have a little bit of experience, and some of you do not have any experience to exposure to Python, which is perfectly all right. We have. I mean, there is no such prerequisite for now because we will be starting everything from the scratch. So do not worry about not having a exposure to Python. All right. So with that, we shall get started. And as we start, I would like to start with a simple walkthrough of the objectives of this class. Okay, objectives, when I say what all we would be learning, I would just like to make some pointers. Okay. So we will talk about data structures of Python. And probably before that, we'll talk about introduction to big data and data science. One thing I want you to make sure is do not get confused with these terminologies. There are a lot of terminologies, more or less, all of them give the similar meanings. We have, we'll get introduced to what big data and data science or machine learning is all about. Then we shall talk. I think some of Sahil, anybody, whoever is on air, I think you have to mute yourself because, okay, I've done it. Yeah, thank you. So otherwise my voice will come back, right? It's kind of an echo. So then we will talk about the data structures of Python in terms of, to learn any programming language, data structure is the basic building block. So we will talk about the data structures of Python and probably a little bit about additions, iterations, or modules and packages, for example. Okay, so we will limit the as to how depth we would like to go into the programming, because this is more of a data science program or class. So once we have the basic understanding of working with Python, we will talk about the modules like NumPy and Pandas. These are some, you can say, these are external modules built in Python, especially for data science. Okay, because Python is not for data science; it's a general purpose programming language. So they have built extra packages on top of it to help doing analytics using Python. All right. Then with this, we shall get started with um, statistics, or in other words, I should say, okay, descriptive statistics. However, statistics and statistical tests. We will go ahead explore. So we'll understand what the data science, what data science is all about. Then we will learn the tool Python in terms of how to use it. Uh, once we learn basics of Python, then we shall go ahead exploring the packages which are built especially for data science in Python. And with that, we shall go ahead talk about the statistics and statistical tests, which is again the basic building blocks for data science, right? Data science is all about analyzing data, and analyzing data, when you say there is a lot of estimations, when you talk about estimation, again, mathematical and statistical estimation, right? So statistics is the foundation for machine learning as well. So we will learn that. Then we will go ahead understand how to perform exploratory data analytics. Exploratory data analytics, when we talk about any given data, how do you analyze using some of the descriptive statistics techniques? And also you can consider data visualization, right? That is, suppose you are given with some data and you are trying to analyze it. After your analysis, you should be able to visualize. That means, suppose you have done some data analysis and you're presenting to your officer, okay? And the officer need not to know data analytics techniques in terms of what hypothesis are you trying to present, what is the mathematical intuition behind it, what is the mathematical equation behind it. The officer need not to know all that, isn't it? So all he wants to see, I mean, you should be able to present it in an understandable form. That is data visualization, isn't it? So we will also learn, understand about data visualization, though the data visualization here is limited to just using Python to generate charts and reports, etc. Um, in the future, you can easily, um, you know, transition into advanced visualization tools such as Tableau, ClickView, etc. Okay, Power BI, etc. And once we are done with this, then we shall get into machine learning. As part of the machine learning, we will talk about supervised supervised machine learning algorithms and unsupervised machine learning algorithm. Okay. So probably this part of the class would be done in your premises. I'll be present there on Monday and Tuesday. Until then, I think we will be going through these topics, and also an introduction to ML would have been done by then. Okay. And so this is the objective for this overall course. Any questions here? Are we all good? And often I will be asking you to acknowledge only to make sure, because we are on an online class, only to make sure we remain on the same page. I may expect the acknowledgement on the chat window is fine. Okay. So that I will know we are in sync. Okay. So
Pawan, one thing from my side. Hello,
yeah, please.
am I audible?
Yes, you are.
Yeah. Okay.
Please.
Okay. I hope that probably you're having the 5 days schedule which we have offered. So we are going as per that, because a lot of things are there in that the topics which I'm finding like unsupervised learning and pre-processing. This is also part of it, and representing data and engineering features, model evaluation and
Just,
improvement.
Yeah, go ahead.
Yeah. So then algorithm chains and pipelines. These are the topics which are mentioned in the curriculum which we have.
Is this not the one?
Yeah. Yes.
This is the one? Is this the topics? Okay. What you can do is,
I will send the topics which I'm possessing. That I will send it to you on your mail. If you can share your mail ID, I can share that also.
Yeah, I can do that. Or if you'd like to just share your screen, anything is fine.
Vishal, do you have the paper on your screen?
Yes, sir. I can share the thing, sir. Just
Okay.
30 seconds, sir.
And why machine learning? Why Python, scikit-learn, essential libraries and tools, Python 2 versus 3 versions used in this book. I don't know. However, then we have the application of classifying iris species. You see this point G here belongs to supervised learning. Okay, there is a mismatch. Anyway, that's fine. Then the classification and regression is nothing but supervised learning. Generalization, overfitting, underfitting, all this belongs to supervised learning. So this should be fine. And in the unsupervised learning and pre-processing, the types of unsupervised learning, it's again clustering. There are different methods there, and challenges, what kind of challenges you may come across. Pre-processing and scaling is part of both supervised as well as unsupervised. Dimensionality reduction, feature extraction, manifold learning, all these are part of something called as data preparation, which is again which belongs to both supervised and unsupervised. And we will also learn to create a cluster. Okay. However, representing data and engineering features, again, what are categorical variables, what is binning, what are linear models and trees, we would have learned here itself. And interactions and polynomials, nonlinear transformations, how do you do feature selection? All this belongs to, again, data preparation techniques, preparing data for machine learning. Model evaluation and improvement, I generally never complete a program without doing this, because this is very, very important. Okay. And it helped, thank you for sharing this.
So there
How
is
it
one more
helps me
page. I would like
is,
to change the screen, sir. That there is
sorry.
one more page. There are like headings 6, 7, 8 as well. So
Yeah, please.
I will just share that as well.
Yeah, one more page is there. One more page is there.
Yes, sir.
Yeah, sure, please. Algorithm chains and pipelines, parameter selection with pre-processing, building pipelines, grid search, all of this, again, it belongs to the data model evaluation. How do you put multiple models together, put multiple parameters together, and find out the best out of it. And working with text data, this is where this was not included in the whatever I have mentioned here, so that will help. So text mining. Otherwise, when we say supervised learning, there, in fact, as we go forward in a while, I will be talking about the life cycle of data science, where I would actually be explaining what is data preparation, why we would use it. So all that will be inside this itself. And the reason why I chose to note it down was because the content I had was this, and actually here, not much machine learning based topics are given, but considering that all they have given is just basics of Python and stats, and because the heading says 5-day data science, I took the freedom to add ML everything. But now that we are on the same page because the same thing is given here. So working with text data, we will understand this. Then wrapping up, approaching a machine learning problem from prototype to production, testing production systems, building your own estimators, where to go from here. Okay. So we shall be learning all of this. Okay. Anyway, this helps to keep in the same context. However, can you just go back to the previous page?
Right, sir. Yeah. Where is it,
Yeah.
sir?
Yeah. Thank you very much. So, okay, so we are good. So probably with this, what I understand is we may not want to spend a lot of time over here or even here. However, whatever is required in terms of Python, we shall learn. We shall learn so that the rest of the course goes smoother. All right.
So do you want me to email it to you, sir? Like,
You can. Yeah, I'll give you my email ID. You can go ahead. Can also actually ask the vendor to pass it on to me. Anything is fine. You can also send an email. So I'll just pass on my email ID. Yeah. You can
Yeah,
send
no problem. We'll send it on your mail ID. Not an issue.
Yeah. Take your time. I won't need it right away. You can send it in your break.
So yeah, we can start the flow. Whatever you have decided, we'll go with that, and later on, minor modifications can be done in your flow.
Yeah, absolutely. So, and as I said, there is no modification required actually. All we had to add was just this, because when I say ML, all of that data preparation or say the pipelining, that is, evaluation of machine learning models, everything is included over here. So we just had to add text mining. That is, so far till here, we would have learned how to work with, say, numbers or categorical data. Now here, we would also learn how do you analyze and build machine learning models on the text data, on the human understandable language. How do you convert that as, say, numbers or patterns, and how do you learn to understand that or analyze that? Okay, that's the only difference. All right. So with that, uh, shall we get started? Any questions or anything you'd like to
Yeah,
add?
Pavan, one thing, just wanted to ask, like as we had discussed few days back, what we have loaded as a software IDE, we have loaded Anaconda.
Yeah.
I think on open source it was 3.9 version was available, so that we have loaded. Anything else in that? Lot of sub IDs were there. What needs to be loaded? You can just tell. Meanwhile, our team will, in case something is missing, so they will get their IDs updated.
Yeah, yeah, I'll do that, sir. So all we need is Anaconda for now. And in Anaconda, when you go to the Anaconda Navigator, when you hit the Anaconda Navigator, you'll see the list of IDEs, that is interactive development environments available. You just have to load Jupyter Notebook there, which won't take a lot of time. If you already have Anaconda installed in your machines, then I think we are good. We'll just get introduced to data science and big data. And then when we start the hands-on, probably in another hour or so, then we will go ahead with the Jupyter Notebook. So it should be fine.
Right. Okay. Thanks.
Yeah, yeah. And all right, so let us get started and let's understand what data science is all about. Okay, so you see, in the last decade, or say last 15 years, for example, there is a lot of change in the way we have been living, isn't it, everybody? So if you go back to 2005, for example, we did not have a smartphone like we have today, right? So which is enabling us to do a lot of things, such as, wherever I am, I can order food. Wherever I am, I can have a cab coming to my location itself. I can there is e-tailing. I can order anything online and get it home. Most of it is possible today because of the social media. Okay, especially GPS is playing a huge role there. Though back in 90s itself, the GPS system was said to be the game changer for the world, right? It actually took another 10 or 15 years for it to actually gain or produce applications which are really useful for human beings, right? So likewise, we have been seeing a lot of changes in the world because of some of the technologies. In fact, it is called as SMAC. As for social media, you have the uh, for mobile, you have analytics, you have cloud. Okay. So now, very simple words. When we talk about data science is all about learning from the data. Okay, more or less, it's all about learning from the data. Okay, so learning to analyze the data, that way understanding the business or understanding a patient, understanding a customer, whatever the data is about, right? For example, if somebody worked as a salesman for 10 years in a given retail mall, okay, somebody worked as a salesman in the Reliance Mall, for example. Today, he becomes a sales manager, right? After 10 years of experience. Why did he become a manager? Because in the last 10 years, he has learned about customers, about products, about a particular season of the month or year, how the sales would be. He have gained a lot of understanding about all of this because he has worked there, right? So anywhere, for that example, for that matter, right? So the more experience you gain, the better position you would be in, right? Be it retail, be it insurance, banking, any segment for that matter. The more years you work on something, you get to be called as a senior because you have gained more experience, isn't it? And you are promoted to be a decision maker, right? You will be in a decision making position with experience. What does that mean? You have learned more, so you are in a decision making position. So analytics, when we talk about, it's the same thing. You are trying to gain that 10 years of experience a salesman has gained in a retail mall. I will give you the same 10 years data. You analyze that data, gain the experience that he has gained. He gained it by working there. We are trying to gain the same experience by analyzing that sales data, understanding the in and out of sales in terms of what products are highly sellable, what products are not really sold well, in which days of the week the products are going well, in which weeks of the month it's going well, which months of the year is it going well. Right now there's a festive season going on. Okay, we are all in Bangalore, by the way, so there is a festive season. So um, uh, a specific type of products will be sold more, isn't it? So like sugarcane, for example, for tomorrow's festival. So um, so that's what analytics is all about. Okay. Why has it become so important? Why is it called? You see, data science is called as the most sought after industry uh, of the 21st century. And it has gained a tremendous demand. And why is it? If we look at, so then we go back to the history. You see, do you think machine learning is a new technology, everybody? Do you feel machine learning algorithms, or say AI, as they call artificial intelligence, for example, are these new technologies? What do you feel? You can say yes, you can say no, anything in the chat window. Okay, thank you very much. So they are not new. I did not see the messages. So yeah, now this is fine. All right. They are not new. So in fact, if you go back by that, then back in 1960s itself, the Alan Turing has proposed, the machine learning uh, algorithms, right? Or even back in 60s, you can talk about neural networks as well. However, there is a huge gap of 40, 45 years for us to really use it practically. And why is it? Because, okay, let's not talk about machine learning yet. Let's just talk about data analysis. If we see why there is a huge gap, it's because only when you have data, you have a need to analyze it. Okay. So now, for example, there is a small grocery shop in, say, Marathali. Okay. And all of, suppose, we are all living nearby. And for the last 5 years, we are all going to the same grocery shop, which is a small grocery shop in the area. We are going there for all our grocery needs, for example. Okay. This retailer uh, whom we visit have only 50 customers, for example, around. And all of these 50 customers are almost 5 to 10 years old, meaning they've been purchasing from him for the last 5-10 years. It's a small data for him, right? He will subconsciously learn about each and every customer because the volume is less. So if I go today, ask for a product, he won't ask me which brand do you want? Do you want a costly one? Do you want a economical one? Because he knows me, right? He have learned about me. So you don't need a machine system there. Rather, if you go to the Reliance Mall every once in a week, they will not know that you are a regular customer because it's a bigger mall. The footsteps is much more than what this small retailer gets, right? Thousands of people are visiting this Reliance Mall every day, and nobody can learn about the buying behavior of all the customers over there. So what do they need? They need a machine to take all this data and later do analysis. However, coming back to the evolution, or why did data science get a lot of demand all of a sudden? If we look at, we have to go back and talk about data. What is big data, by the way? When we talk about it, back in 90s, we had the evolution of .com, right? We had the evolution of .com, www, right? The internet evolution has happened. And then also we had the evolution of personal computers, isn't it? So you got the personal computers in place. People can own a computer, and we had the .com internet available for everybody. And with this, the era of internet or digitization has actually begun, right? Then back in 2000s, if you see large corporations like Facebook, for example, Yahoo, Google, right? These large corporations started bringing business online. They started bringing businesses online. And on the other end, the customer have or the people own computers and they have access to internet. So more and more people started using these services, which are free of cost, right? So using Google, we don't need to pay money, or using Facebook, or back then we had Orkut and other social media platforms, for example. Okay. So you see, or even the businesses such as Alibaba, or the online businesses. For example, we had Yellow Pages and so on. Okay, Yellow Pages was not an online thing anyway, back then, I believe. We had a lot of businesses online. Now the challenge is, see, if we go back by 1980s and so on, these banks or other corporations, for example, how did they store the data? Okay, most of the data is actually not digital, isn't it? At least the attendance, for example, attendance was not digital. Even the schools that we came from, our attendance was not digital in schools, isn't it? That was the time. And slowly, why was it so? When you look at the cost of the storage was really uh, okay. Um, let us go back to the flow again. See, this was the case. We had internet, we had personal computers, and we have businesses started online. So most of these businesses are based on data, right? If Google did not collect the data of customers, of people who are visiting the different pages, it would not have monetized the advertisement market, isn't it? Same goes to Facebook. Same goes to many online businesses, right? Advertisement is the key. To advertise, they have to learn what kind of person he is and what is he search looking for, and accordingly they promote products, isn't it? But then there was a challenge. The challenge that we are talking about is, see, with the evolution of data, we had a few challenges which are also called big data based challenges. These are very popular, and I don't know if you would have attended some webinars into big data, you would have heard about it. Some of the big data based challenges are, the first one is volume. Volume is, see, go Facebook or Google, any other company, so they are collecting a lot of data. Cost of storage was one of the key challenges. Cost of storage. See, today, if I want to store 2 terabytes data, how much money do I need to spend? If I have to store 2 terabytes of data, all I have to do is just buy a portable hard disk, isn't it? I can keep that hard disk on my pocket and roam around. That's all I need to do, right? So it's such, I mean, it's affordable today. So if you go back to the 2000s, the year 2000 or 90s, it was not so, right? The cost of the storage was really huge, and it was not really portable easily, right? So though you had these CD disks and everything, it was not so easily portable, and the data storage, the volume itself was pretty less, and you had to pay a lot of money for it. So for some of these volume based challenges, if we look at, you know, the banks, they were using IBM mainframe. Even today, it's being used. However, see, when you use traditional database management systems like RDBMS, right? Whenever you use traditional, the RDBMS, relational database management systems, there is a limit to the amount of data that you can store. Okay, there is a limit. So suppose you have a server, here, and you have all the client machines around. Okay, and you have, say, you have stored some 10 terabyte data here, 10 terabyte data here, 10 terabyte here, and 10 terabyte here. Now you have one more. Okay, all this entire environment is full of data. It's all, they have all reached their thresholds. Now you have more, 10 terabyte more data. What you need to do, you need to add one more machine to this server. To add this machine, when we talk about RDBMS, like Oracle or SQL, MySQL, right? You have to pay money for it. It's not free, isn't it? It's what do you call it? It's called the, just a moment, licensed software. These are all licensed softwares, and you have to pay money in order to use them, isn't it? Okay, so that way this is costly, volume and cost of storage. Then okay, I think it's good enough. So basically RDBMS. See, for example, what these banks used to do was, for example, suppose they have a server of 1, 2, 3, 4, 5 machines. Okay, there are 5 machines in their server. Okay, or you can consider a rack of 5 servers, and in each of them maybe there are 5 machines, whatever. Suppose this is a server, they have 5 machines. Okay, so each machine can store 1 terabyte of data. Okay, so suppose here you have one total 5 terabytes of data that belongs to the customers from 1980, till 1990. Okay, consider this is 10 years bank customers data. Okay, now the storage is full. What they have to do, they have to bring more machines, but that is not affordable. So what they will do is they will flush out all the data from these 5 machines and store it in the form of a tape and probably put it somewhere in a treasury. Okay, so that the data is safe in locked up in some treasury, and these machines are now free to store more data. Now what I will do, I will put 1990 till 95 data over here. Now we have a new manager coming in, and for this Sankranti, for example, he wants to give an offer. He have a new sales strategy. Okay, for this Sankranti festival, we want to have all the customers in the last 15 years, whoever have kept a consistent balance, we are going to give them some offer or discount or some gift. So the manager calls the data analyst asking, I want to see in the last 15 years, how many have kept a consistent balance of some amount, for example. Now, what should data analyst do? This 10 years data is in treasury. This 5 years data is readily available. Though they have collected data, they don't have it right away with them in order to analyze it, isn't it? This is in fact called as the premature death of the data. Though you have it, you are not able to analyze it. And today, you see, if we talk about in terms of businesses, the data analysis is the backbone. However, even in other words, if we talk about it, collecting more data helps you gain better understanding about anything, right? So, in a in in the other parts of the world today, we see a lot of we see different use cases. For example, in China, they are keeping the cameras in the classrooms in order to hidden cameras in the classroom in order to capture every facial expression of a student, and then they are trying to learn what kind of sentiment the student has for a given topic, for a given teacher, and in a given time period of a day, and different things. Just trying to understand from the data what is actually happening, right? And there are a lot of use cases when we talk about different business sectors. So data analytics is not for one domain. Wherever there is data and we want to analyze it and understand about things the data belongs to, these tools helps us do it better. Okay. However, before I go forward, just want to know, are we all good? Am I getting you bored with a lot of theory? You can be very straightforward. It should be fine. So if you are getting bored with theory, I can quickly wrap it up and get started with Python programming as well. So what is it, everybody? Are we all good? Can you all hear me?
We can hear you, sir. We can maybe we can start with the programming part.
All right. Okay. Sure. Thanks for that. So let's go ahead. So volume is one thing we discussed. Then there is velocity. Velocity, when we talk about today, there is a lot of data which is coming in a faster pace. And how do we manage that is another thing that we had to talk about. So basically, again, here the speed of data generation is really an issue. And okay, that is another issue. Then there is um, variety. Variety, when you talk about in social media, for example, I am taking very simple examples of generally social media and retail and banking, insurance, easy to understand. So variety, when we talk about, again, today the data that we are generating is in different formats. Okay. Uh, for example, if you talk about the some social media data, there are likes, there are comments, there are images, there are GIFs, video data, all are different formats of data, right? But when we talk about these standard tools like Excel, for example, like SQL, for example, when we talk about SQL, data should be in a structured format. For example, you have the you have a column where all the names are present, numbers are present, their email IDs. So this column should be of type integer because it's serial number. It could be integer or float, right? This column has to be string because it's names. This column has to be phone numbers. This column has to be text data again, email IDs, right? So this is structured data. Okay. But now in the internet, most of the data we are generating is actually unstructured in nature. So how do you tackle that? This was also a problem, and along with that, it was veracity. Veracity is nothing but the authenticness, correctness of the data. Okay, just because you have the right, just because you have a lot of data, it does not become a use case for big data analysis unless you know it's the right representation of the business. For example, we are collecting attendance in college every day. If a guy keeps getting proxy every day, and end of the class, end of the year, you are analyzing the attendance, and he has got 100% attendance, doesn't mean it's a right result because he was not present. It was proxy, right? The data, we have to make sure data we are looking at is the right representation of the business, for example. All right. So these were all the challenges faced the early 90s and 2000 by large corporations. Again, why did I say particularly large corporation? Because if your organization is small, if you have a smaller amount of data, then you are not running into any of these problems such as volume, velocity, variety, anything, right? Because the data is small. Only when the data is huge, when the data is, for example, there is a black box data that you're getting, right? Then you have a lot of details like latitude, longitude, etc., which makes a lot of data. So you need, in order to analyze it, in order to store it, manage it, process it, and analyze it. Okay. All these challenges were actually tackled, or the answer to all of this was a distributed management system called as Hadoop. Okay. Not go in depth of this, just tell you the basic thing. Hadoop is basically a data engineering platform. It has two components. HDFS, which is called distributed file system, is a storage layer of Hadoop. This is where you place all the data in Hadoop, the component of Hadoop. If you ask me how is it different from the traditional RDBMS, basically this is open source software. You don't pay money for this. It's open source. And for these RDBMS, right, you need high-end costly servers. And in this case, that is not required. Open source, and it can work with just commodity hardwares as well. So that's what it is. This is the Hadoop storage layer. It's actually distributed in nature. It's a distributed file system. It's open source in nature, and you don't need to have high-end servers in order to have Hadoop. In order to have a Hadoop cluster, Hadoop cluster is nothing but a cluster of group of computers, and in all of that, Hadoop should be running. And the other layer is called MapReduce. MapReduce is a processing layer of Hadoop. So processing, when we say processing, is nothing but reading. Okay. Suppose I have 10,000. Okay. Let me open something. Okay. See, there is some data ran. Okay. So now there are 500 records. Suppose I want to read which house has a room, which house has rooms more than five, which house has more than 5 rooms. I'm able to filter something, right? That is called reading or processing. Okay, this is called reading or processing. Now, MapReduce lets us do the reading of the data, and it is a parallel processing layer. Okay, so it is parallel processing. When we say parallel processing, for example, suppose we had to clean garden. Okay, one guy starts doing it, he may take 1 hour. Now, if 10 of us come together and start cleaning that garden, the work is done within maybe 15 minutes, because multiple people started working on it at the same time, right? So that's a concept called as mapper and reducer. So mapper is like 10 people start doing the same task on different sets of data. Then they come up with 10 results. All that 10 results is merged together, aggregated, right? That is reducer. For example, you have 10 lakh records of employees. We want to know who are those employees who are getting more than 2 lakhs as salary. Now I will give this task to 10 people. So first mapper comes with, okay, I have 100 people with me who are getting more than 2 lakhs salary. Second mapper came up with, I have 77,000 people with me who are getting more than 10,000 salary. Maybe 500 here, 50 here, whatever, right? These 4 people came up with 4 different results. Overall, how many people are getting more than 2 lakh salary? If we want to count, it is 7,650. That is the reducing logic. Okay. These are different mappers. mapper 1, mapper 2, nothing but parallel processing. Okay, instead of one processing, there is 4 different processing taking place here, and all of them put together at the end. Okay. So just a moment. Okay, so this was a brief history of big data, Hadoop, which has actually opened doors for analytics. And this is how data science and analytics became the most sought after job or industry of the 21st century. And why is it? Because we are able to, I mean, we are in a digitization era. There is a lot of data that is getting collected everywhere, and you see, if I start from here to Marathalli, for example, I will know exactly how much time I will take because of the maps again. And again, what is map? Again, that's a collection of data. You know how many people are stuck in traffic in a given road, and you have the route optimized for you so that you can reach earlier than you can reach if you would have taken a normal route. So all of this is enabled by the data analytics and the technology, right? So, all right. So without much ado, I think we shall get started with data science from here. Hadoop also has multiple components like Big Hive for analytics. Okay, the scope is very limited for now for us in this class. We shall go ahead talking further about data science. So I feel we will just complete the flow of data science life cycle, which will be good. However, if you'd want to move on to programming first, later come back to this theoretical part of it, it's okay. What would you guys prefer? I already have one feedback. Uh, okay. Okay, maybe we shall move forward into programming. We can complete the intro to data science. Yeah, that's what I feel as well. So what is your programming after theory? Programming, please. So now that's a mixed opinion. Okay. Complete the intro, some of you say, and some of you want to move on to programming. Okay. Let me do one thing. For now, I'll keep the introduction simple and then I shall move to programming. Okay, please bear with me on that. And all right, I'll not take much time here because we've already talked about things, so don't worry about it. And I am actually not going to talk about the applications of data analytics in the industry. Like, for example, see, data analytics is there today everywhere. Okay, everybody, because today India has done exceptionally well in the digital payments, right? Uh, no other country is able to do what we have done in terms of digital payment, isn't it? Everywhere, even a I mean today even a street vendor have Paytm, Google Pay available, right? Or any UPI payments available. So even that is data for you to analyze. So there is no place where data analytics is not used. As long as there is data getting generated, there is some analysis. And see, human beings are have been doing this by default, right? When you meet a friend, we have a calculation about him. How is this guy? Even that is some analysis and estimation, isn't it? So doing it using tools is what this is called. So basically that is used in customer analytics, in retail domain, for example, to understand about a customer, his purchasing pattern, his behavior, the sales pattern and things. Then the experience analytics. How is your experience in a given restaurant, in a given mall? Oh, right after this class, there will be a feedback thing, right? Analyzing that feedback. Threat analysis. Again, all I know is, for example, in an oil and gas industry, analyzing the threat of a oil leakage using different parameters. Risk analysis, again, uh, you know, the risk behind giving loan to somebody, in simple words, right? There are a lot of fraudulent transaction analytics, brand sentiment analysis, right? You guys, you would have heard about this, like, the politicians these days, they use online platforms like Twitter, for example, right? Twitter has made, I mean, there is a lot of pros and cons there, right? We are all aware of it. So they are trying to analyze the sentiment of a person uh, towards their party by analyzing their tweets, right? Is he is he a potential voting candidate to my party? Is he talking good about me in Twitter, for example? Okay, so there are a lot of use cases. All right. Let's go ahead, talk about the life cycle of a data science project. Okay, so whenever we talk about data science, there are two things. This is like going to a doctor. When we go to the doctor, he does two things. First thing is he does a diagnosis to understand what is happening to this patient. That is historical data analysis. Based on the diagnosis he has done, he will decide the future actions, right? So that's what data science is all about. There is analysis of historical data, and based on that analysis, based on that understanding, decide the future. Only two things, okay? I hope you are getting it. Diagnosis and decision making. In fact, there are different terminologies for this. This is called descriptive statistics, diagnostic statistics. There is predictive statistics, or let's call it descriptive analytics. Sorry, descriptive analytics, and you can call predictive analytics, and diagnostic analytics, predictive analytics, descriptive analytics. See, what this means is descriptive analytics meaning basic things like mean, average, maximum, minimum, things like that. Diagnostic is, again, you are analyzing the historical data, okay, in depth. Based on your analysis, you have gained some understanding. You are going to predict. For example, considering this in the doctor's perspective, right? Doctor has done the diagnosis. Now he has understood about the patient's illness. He will predict what tablets to give. Then he will prescribe that, right? Keeping it very, very simple. So one thing I would want you guys to know before we go ahead anywhere. See, there are a lot of terminologies in the industry. Somebody may call it data analytics, somebody may call it business analytics, somebody may call it data mining, somebody may call it knowledge discovery, so on. But It's all more or less same. So do not worry about these terminologies at all. Okay. Somebody may call it even machine learning. All right. Now, the data science life cycle, when we talk about any analytics project, any data science or analytics project, when we talk about, follows this kind of a life cycle. Okay. There could be two types of data science projects. In some of the projects, there may not be any problem definition. Okay. You may not be analyzing data just because there is a problem statement. Or in some cases, there is already a problem statement available, and towards solving that problem, you are actually working. Okay. So a project without problem statement. Do you understand what it means? It means you are working towards the development, isn't it? I mean, for example, there is a bank data. You are the data scientist of that bank. You are just analyzing that data in order to understand what all things can be improved in this bank so that the bank is heading towards the development. There is not a specific goal as such. The other type of problem could be bank has already a problem. People are not paying the credit card bill on time. So they've asked you, find out why people are not paying bill on time and what can we do in order to make them pay it on time. This is another type of problem, right? So any data science project for that matter follows this life cycle. That is, the first phase is data collection and validation. Validation is again making sure the data is the right representation of the business. So data collection and validation. This is the first step. This belongs to data engineering. Okay. Collection, or let me call it data engineering itself. Data engineering is a domain belongs to collection, storage, processing, and management of the data. So some of the tools, starting from Excel, but however, you don't store it anywhere. RDBMS, database tools like Hadoop, or even cloud. If you are aware of what cloud is, it's a service which is, for example, I don't have the, cannot afford to have an infrastructure to store thousands of terabytes of data. I can rent the infrastructure which somebody already have. That is cloud-based infrastructure, where I can store the where I can store my data. This is like a, for example, the bank locker systems available, right? So I don't have a safe place to store something very precious. So I am renting a bank's place. The key is with me. Nobody can access it, isn't it? Same thing over here. This is data engineering. Next thing is data analytics. Data analytics includes statistics, mathematics. In fact, more than all that, domain knowledge plays an important role. See, suppose I am an expert data scientist, for example, and I have been given cancer patients' data. So they want me to analyze that cancer patient's data and identify or do something helpful for the patients. If I am a novice, if I am a layman, I don't have any knowledge of what cancer is, or if I'm not a medical person, doesn't matter what statistics, mathematics, or algorithms programming I know, I cannot solve a problem here because I have no domain knowledge, right? It's very, very important. Statistics, mathematics, domain knowledge, analytical skills. Analytical skills is again thinking skills, right? Not everybody can think. Comes out of curiosity, interest, and so many other things. So let me tell you, data science as a domain. I know all of you are from the computer science background. You would have done programming, for example, but data science is not that really. Data science is a pure field of research. Only if you have curiosity, only if you have interest in exploring something, in unveiling something which is hidden deep inside. That's why it is called data mining, isn't it? So you don't just dig for the sake of, okay, they asked me to dig looking for gold. I'll just dig a couple of feet and then I'll say, okay, gold is not there, let me move somewhere else. Only if you have the real interest of digging deeper till you get the gold, that's what this field of data science is all about. It's a field of research. Okay. So some of the tools which are used generally, or is the most widely used data science software out there. Since all of you are from the Python programming background, then should be fine. There are other tools like SAS or SPSS and so on, MATLAB and so on. Data analytics. Okay, you have collected, stored, and managed the data. You have analyzed the data. What next? Upon analyzing this data, we have gained a detailed understanding of business, for example. What next? Suppose I want to present it to my senior who is not from the computer science background, some decision-making person. I have to present it to. I have to create it. I have to present my analysis in the form of reports, in the form of presentations, isn't it? In the form of reports, in the form of presentations or charts. This is where data visualization domain comes to help, and do data simple charts using R and Python as well. However, advanced is Tableau, ClickView, Power BI, and so on. Okay. Unfortunately, all these three are licensed software, not open source like R, Python, or Hadoop is. Okay. We got to pay for it. Then after data visualization, what comes next is advanced analytics. Advanced analytics is nothing but machine learning and deep learning. Deep learning is also can be called as neural network for your understanding. I'm going to say neural networks, and both are same. Okay. Deep neural networks are deep learning. We will talk about this later. Okay. This is about now using this. We know the history in the mall, how the sales is happening for the last 10 years. I know. Using this advanced analytics, most of it is supervised learning is all about prediction. Okay. Predictive. Doctor now have analyzed a diagnosed patient. Now he have to decide what has to be done in the future. That is this advanced analytics. And to do this advanced analytics, there is a step and that is called data preparation. That is preparing the data for analytics, like data pre-processing, feature selection you have seen your outline. Then there is just a moment. Dimensionality reduction techniques. Dimensionality reduction. This is also unsupervised learning. With that, finally, the evaluation of algorithm and performance. This is where all that grid search, pipeline, all of that comes. Okay. Finally, in a sense, data analytics project is all about take the data, analyze, visualize, do something advanced, like which helps your decision making and problem solving. Okay. This is what this is how a data science project goes, everybody. Any questions here? Okay. So if you do not have any question, we can move forward into Python. And are we all good? I hope I did not rush through. And any point of time, if there is a miscommunication, or I mean, if there is a concern, please feel absolutely free to tell me. Okay.
Yeah, Pawan, go ahead, please.
Yeah, thank you very much. So let's get started. So let's go ahead, open the Jupyter notebook. So we are starting to learn Python. Before I get to Python again, there's a little bit of theory, nothing much. Python, why Python is another question, right? Why Python? See, there are tools, there is R, there is Python. There are many other tools like SAS, SPSS. See, these are all licensed, okay? SAS, SPSS, there are hundreds of such tools. They're all licensed, okay? So these are the two most widely available choices, R and Python, which are open source. R is completely built for statisticians and analysts because it does not need a lot of programming knowledge. Python requires you to be having some programming knowledge. However, Python today, in many ways,